This is where ICMP scanning comes in. ICMP scanning is a very advanced, a very good, effective information gathering technique that can be used to find out a range of different types of information about the target computer, including the operating system running on it. So how does ICMP scanning actually work? We sort of have discussed ICMP scanning, if you remember, during the ping example or ping sweeping example. Now ICMP, or the Internet Control Message Protocol, is the de facto or standard protocol used for reporting errors that might have occurred during the data transmission process from the source computer to the destination computer. In other words, the ICMP protocol is responsible for reporting any errors that take place in the data transmission process. Originally, the ICMP protocol was designed for network diagnosis and troubleshooting purposes, and of course for error message communication as well. However, nowadays ICMP scanning has become extremely useful and important for information gathering purposes. So there are numerous possible ICMP query messages that can be created, that can be sent on the internet. When a host receives a particular type of ICMP error message or ICMP query message, then based on its operating system, a predefined response is sent. I like to repeat this because it is extremely important and is the crux of ICMP scanning. Now each ICMP message that is generated could represent a particular request or could represent a particular error message. Now when a particular system receives an ICMP query message, then the response that is created by that particular system depends on the operating system running on it. So say for example, when an ICMP query message is sent to say a Unix system, then the response that is sent back is very different to the response that is sent back when the same ICMP query message is sent to a Windows system. So based on the operating system that is running on your computer creates the response to certain ICMP query messages that are sent to it. This particular response that is generated varies from OS to OS, and the contents of the reply message generated due to the query messages received by the particular computer also vary from one OS to another, and they are same for the same type of OS. In other words, if there are two Windows systems which receive the same query message, the response or the reply sent back by both the systems is going to remain the same. In other words, the response of a host to a particular query message received by it depends on the operating system running on it. The same ICMP message sent to a Unix system and a Windows system will generate two different responses. This difference in response that is generated when the same ICMP query message is sent to the target computer is then used to determine the operating system running on it. So the working of the ICMP scanning can actually be broken down into two main steps. Step 1 is the attacker sends specific, manipulated, specifically generated ICMP query messages to the target computer. Now the target computer, on receiving this ICMP query message, will obviously send back a reply. Now this particular reply, when it reaches back to the attacker will record the reply using a recorder or monitoring tool or a sniffing software, and once it is recorded, it is then compared to the table of known responses, and the exact operating system running on the target computer is determined. Because most attackers or most people already know, say for example, if an ICMP message is sent to a Windows XP system, then this is the response that we're going to get. If the same ICMP query message is sent to a Unix system, this is the response that we're going to get. So once we get the response, you simply compare it to that chart which contains the known responses, and you can easily determine the operating system name or operating system version running on the target computer. So ICMP scanning is quite simple. You send a particular query message, receive a reply, record that particular reply, compare it to the known values, known types of data which have been recorded or which have been created over a number of years by computer security experts who like to experiment in this particular field, and by comparison and by testing you can easily figure out what operating system is running on the target computer. Network reconnaissance. Now typically ICMP scanning is carried out to find out a wide variety of information about the target computer. It is used for host detection. Yes, you are right, it is exactly what the ping tool or the ping sweeping tool did earlier in the information gathering module. Operating system information. ICMP scanning is essentially used for OS detection purposes. It can also be used for network topography information. If you remember the traceroute tool, you'll know exactly what I'm talking about. It can also be used for firewall detection purposes. Again, this is related to the traceroute tool that we learned and discussed earlier. So before we move on to the various types of ICMP scanning techniques possible, I'd like to describe the format of a typical ICMP error message. Each ICMP message has a code and a type value whose unique combination corresponds to a specific error message. For example, this will be clearer after the example. Say for example, there's an ICMP message which has a type value of 3 and a code value of 3. Then the error message that the particular ICMP message carries is the port unreachable message. On the other hand, if an ICMP message contains a type value of 3 and a code value of 2, then the error message that it corresponds to is the protocol unreachable error message. Depending on the values stored in the type and the code field, the ICMP error message carried by a particular ICMP message can actually be determined. So we'll now move on to the various types of ICMP scanning techniques. There are a number of different types of ICMP scanning techniques. The first type of ICMP scanning technique is the host detection technique. And yes, for all those of you who recognize this technique immediately, you are correct. This is indeed the ping tool. This technique reveals to the attacker whether the target computer or the particular host is online or not. It makes use of two ICMP messages. One is the echo request and the other is the echo reply. The working is quite simple. The client sends an ICMP echo request to the target computer. If the target computer is online, is alive, is connected to the internet, it sends back an ICMP echo reply. On the other hand, if the target computer is not connected to the internet, there will be no response. So depending on the response that you receive in step 2, the ping tool or the ICMP host detection technique can be used to figure out what computers are connected to the internet and what systems are offline. Now this host detection ICMP scanning technique can be used for a wide variety of purposes. First of all, it is used for host detection to determine what systems are live, what systems are not alive. It can also be used for DOS attacks. We will be discussing that at a later stage. They are also used for firewall detection purposes. So what are the various countermeasures that are possible against ICMP host detection scanning? Now echo requests or ping requests can easily be filtered at the router level using a simple access control list, which is access-list 101 deny ICMP any 8. And as soon as you create such an access control list, all incoming ping requests or all incoming echo requests will be blocked and the ICMP scanning or ICMP host detection technique will simply not work. There is also a variant of this particular ACL which allows ICMP echo requests from certain IP addresses, which is also being displayed on your screen for those of you who are interested in that particular ACL. The second ICMP scanning technique is the timestamping technique. This method was originally designed to allow one system to find out or determine the system time of another system. However, nowadays it is also used for OS detection purposes. The working of this particular software or this particular technique is quite simple. First of all, makes use of two types of ICMP messages. One is the timestamp request and the other is the timestamp reply. So the various steps that are followed in ICMP timestamping are: step 1, the client or the attacker sends an ICMP timestamp request to the host. When the host receives this message, it will immediately send back an ICMP timestamp reply to the attacker or to the client. Now, when the client receives this reply, the reply can actually be analyzed and can be studied to determine the OS running on the target computer, because the reply that is sent out is dependent on the OS which runs on the target computer. So based on what we had discussed earlier, the replies that are generated when an ICMP query message is received by an OS is OS dependent. So a reply created by a Linux system will be different from a reply created by a Windows system. So due to the difference, you study the reply received, compare it to the known values, and determine what OS is running on the target computer. Countermeasures of ICMP timestamping are quite simple. All you got to do is, at the router level, create an access control list, which is access-list 101 deny ICMP any 13, which pretty much blocks all incoming timestamp request messages, as a result of which ICMP timestamping does not work. The third technique of ICMP scanning is the address mask messages technique. This technique is also being used for OS detection purposes, when originally it was designed to help determine the address mask of the remote system. The working is quite simple, very much similar to the timestamping technique. It makes use of two ICMP messages. One is the ICMP address mask request, and the second is the ICMP address mask reply. And the working is, the client or the attacker sends an ICMP address mask request to the target computer. The target computer sends back an ICMP address mask reply, and this reply is then studied and compared to the known replies, and the exact OS running on the target computer is determined. So what are the countermeasures against ICMP address mask query messages? I think it's very much obvious by now. It's very similar to the access control list that was generated for the previous two ICMP scanning techniques. Now, these three are not the only ICMP query messages that can be used for OS detection purposes. There are a wide variety of other messages that are also used widely on the internet, but not as commonly as these three types of messages for information gathering and OS detection purposes. However, I like to share with you certain other not so common ICMP query messages that are being used for info gathering and even for OS detection purposes. The ICMP message quoting query message. Now, the difference in amount of information quoted in the errors generated or the reply sent back is used to differentiate between what OS, or rather pinpoint what OS is running on the target computer. The ICMP error message quenching technique. This technique again studies the reply sent back by the target computer and compares it to the known responses and identifies or pinpoints the exact OS running on the target computer. Another extremely commonly used or extremely effective ICMP scanning technique is the ICMP error message echoing integrity technique. Now, the difference in alterations made in the IP header of the reply received by the attacker is then used to determine the OS running on the target computer. So these are the various other not so common but very effective ICMP related scanning techniques that are used for information gathering and also for OS detection purposes. So what are the general countermeasures that system administrators must take against ICMP scanning techniques? First of all, individual monitoring and filtering of ICMP error messages must be done, especially when the ICMP query messages or ICMP error messages are originating from unknown, untrusted networks. One should change the default values and settings of the responses or replies normally generated by your system when it receives a particular ICMP query message in order to avoid OS detection. Because the entire crux of ICMP scanning is the replies generated when a query message is sent to the target computer dependent on the OS running on that target computer. However, if you change the type of replies generated, then you are going to make it very difficult for the attacker to determine what OS is running on your system. You can also mislead